This is the frequency distribution for the dataset. To construct this, start with the class limit. Find the lowest point in the dataset and the highest point. As you can see from the raw data, the lowest point is 80 and the highest point is 270. By subtracting the highest point from the lowest point, you will get 190, which you can then divide by the number of classes that you want. In our frequency distribution, we divided 190 by 10 classes to get each class separated by 19 data values. After writing down our 10 classes, we found the class boundaries. To do this, first find the lower boundary by subtracting 0.5 by the lower limit. For example, we subtracted 0.5 from 80 to get 79.5 as our first lower class limit. Next, you find the upper boundary, and this is done by adding 0.5 to the upper limit. For example, we added 0.5 to 99 to get our first upper class limit. The next step in creating a frequency distribution table is finding the midpoint, which is found by adding the lower boundary and the upper boundary and then dividing by 2. Next, you find the frequency by looking at the data values and placing them into a specific class. The last thing that needs to be done to make the frequency distribution table the cumulative frequency. This is found by adding the frequency in each class to the total of the frequencies of the classes preceding that class. For example, we added 4 plus 7 to get the cumulative frequency of 11 for the class of 100 to 119. Based on the data set of the number of calories per serving for selected ready-to-eat cereals, I'm going to show you how to construct a histogram. First, start by drawing and labeling the x and y axis. On our histogram, the x-axis is the number of calories, and our y-axis is the frequency. On the x-axis, the values that are used are the upper boundary limits. For example, for this histogram, the values placed on the x-axis were 79.5, 99.5, 119.5, 139.5, 159.5, 179.5, 199.5, 219.5, 239.5, 259.5, and 279.5. On the y-axis, label the values from frequency. These values can be found from the frequency section on the frequency distribution table. For example, on our histogram, we counted to 10 by 2s. Next, using the frequencies as the heights, draw vertical bars for each class. As you can see, this is what we did here. After you're done drawing the vertical bars for each class, comment on the shape of the graph. We said that this histogram is uniform shaped, and that is how you draw a histogram.
Another type of frequency distribution graph is the frequency polygon. It is formed by plotting points and connecting them with one single line rather than using a bar-style graph like the histogram. As you can see, the y-axis of the frequency polygon is the frequency, as found on the frequency distribution table. For the x-axis of this graph, you will use the midpoint. To find the midpoint of each class, you add the upper limit and lower limits together and then divide by 2. The third and final kind of frequency distribution graph we will be using is the ogive. It is very similar to the frequency polygon, however, the x and y axis are different. For this type of graph, we use the cumulative frequency as the y-axis, and the class boundaries for the x-axis. We then plot the points and connect them using one single line, just as we did for the frequency polygon.